Hi, in this video we will talk about why algebra makes sense. So for example, why are we able to rearrange equations, why can we add equations together, and why does cross multiplying work? And so this video is intended for like grade 9 or 10 level or other people who are just starting to learn about algebra and want to understand the concepts behind why we're doing it. So there's really just two big ideas to learn here. So first of all, you can do the same thing to both sides of the equation and it will stay equal. So for example, let's start with the equation 2 equals 2. So we can agree the left side equals the right side because 2 has to equal itself. So if we perform an operation, so for example, we can add 5 to both sides, we get 2 plus 5 equals 2 plus 5, which results in 7 equals 7. And so it's true, 7 does equal 7, so that shows that the equation remains true whenever we do the same operation to both sides. And so this example might seem kind of silly, like we know that this makes sense, but it helps us to realize that the same rules are true when we're dealing with variables. So it's always okay to do the same thing to both sides of the equation. And the second big idea is performing the inverse operation will undo an operation. So for example, addition and subtraction are the inverse of each other, they're the opposite. And multiplication and division are also the inverse of each other. And later on, you're going to learn more about other types of operations. You might have already learned some of them, like squared and square root. But in this video, we're just going to focus on these four operations here. So let's see how this works. So we'll pretend we're going to start with 3, and then we're going to add 2, and then subtract 2. And so we'll notice that adding and subtracting the same number is going to actually undo it completely. So here we have 3 plus 2 is 5, but if we subtract 2 again, that gets us back to 3, which is where we started. And so here, if we start with -6 and we multiply by 2 and then divide by 2, again, these two operations are going to undo each other. So -6 times 2 is -12, and then if we divide by 2, we get -6 again. So these examples show that we can undo a certain operation by performing the inverse, and so this is true with these actual numbers that we used, and it's still true when we're using variables. Okay, so now let's do some examples to practice applying these concepts when we're working with variables. So remember that the variable, such as x, is going to represent a certain number, and the goal here is to figure out what value of x will make this equation true. And so a really good way to do that is to try to get x by itself. So x is alone on one side of the equation and everything else is on the other side. So in this case, we do not want to have this -5 over here. So how can we undo that? Well, we can do the inverse operation, which in this case is adding 5. And so if we add 5 to both sides, the equation stays true because we're doing the same thing to both sides. So here we have -5 and then we're adding 5, so that just gives us 0, that cancels out. And then over here we have 30 plus 5, which brings us to 35. So then we can say x equals 35, and that's the answer. And you can check by subbing in 35 up here where we see x. So if we have 35 minus 5, that equals 30. So that's correct, and we know that we solved this correctly. Okay, so in this next example, we have to solve for y. But notice that there's two operations going on over here. So we have the y multiplying by 3, and we're adding 7. So how do we know which one of these to undo first? Well, we can do the reverse of BEDMAS. So BEDMAS, like order of operations, is helpful when you're simplifying something. So you do brackets, exponent, division, and multiplication in the order they occur, and addition and subtraction in the order that they occur. So here, when we're doing algebra, we want to do this the opposite way. So we're going to start with any addition and subtraction, then move on to division, multiplication, and then exponents, and then brackets, which in this case, there aren't exponents or brackets. So to undo this adding 7, we can subtract 7 from both sides. So here we have 1 minus 7 is -6, and then over here plus 7 and minus 7 cancels out. So we're just left with 3y. And now we can do division to try to get rid of this 3 out front. So if we divide both sides by 3, -6 divided by 3 is -2. And then here if we have 3y divided by 3, we're going to get y by itself. So the answer is -2 equals y, and usually for convention we would say y equals -2, but really it means the same thing. Okay, so now we have to try to solve for b, but in this case we have b variables on both sides of the equation. So usually in a situation like this, I'm going to choose, do I want to have the b by itself on the left side or the right side? and then I'm going to try to get all the b variables to the same side. So I'm going to choose to isolate b on the right side over here. So how do we get rid of the negative b on this side? Well, what we can do is add b to both sides. So just as we can undo an operation with numbers, it also works with variables. So over here we have 15 minus b plus b, so that just gives us 15. And then over here we have 4b plus b, which gives us 5b. And now to get rid of this multiplying by 5, we can divide both sides by 5. So 15 divided by 5 is 3, and 5b divided by 5 is b. So in this case, b equals 3 to make this equation true. Alright, so this is the last practice problem, and so in this case, it's asking us to solve for a. So again, we have some variables on both sides. So I'm going to try to bring all the a's over here to the left side. So to remove the a from the right side, let's subtract a from both sides. So if we look at over here on the left side, we have a plus 1 minus a. So the a's cancel and we get 1. And then over here we have a minus 2 and we're subtracting a. Again, the a's cancel out. So we're left with negative 2. And so look, we notice all the variables disappeared because I was subtracting a to try to get rid of it over here, but it ended up also removing the a on the other side. So now we're just left with 1 equals negative 2. But we know that 1 should not equal negative 2, so what this actually means is that there's no solutions. There are no values of a that will make both sides of this equation equal, because the variable just cancels out and has no effect on the overall equation. So no matter what you make a equal, it's never going to make the left side equal the right side. And instead of getting like 1 equals negative 2, if you had gotten something like 1 equals 1, then that would mean that there's actually infinite solutions. So you can make a have any value and the equation would always be true because again the variable has no effect on the other numbers that are in this equation. Okay, so now we're going to talk about a few different math concepts related to algebra. So let's talk about isolating a variable. So just as we did in those practice problems, isolating means that we want to get the variable all by itself on one side of the equation. But in this case we have two different variables, y and x. So when it says isolate y in terms of x, it means they want us to have y by itself on one side of the equation, and then we're going to have x and some other numbers on the other side. And so we can use these same algebra skills to try to get y by itself. So let's try to keep y over here on the left side, and we're going to try to remove all these numbers by getting them over here with the x. So first what we can do is thinking about the order of operations. We're doing reverse BEDMAS. So first we want to get rid of this negative 1. So how can we do that? Well, we can add 1 to both sides. So on the left side we have negative 1 plus 1, which just leaves us with 4 times y plus 2. And then on the right side we have x plus 1. And so next in the order of operations is multiplication and division. So to get rid of this multiplying by 4, we can divide both sides by 4. So over here the multiplying and dividing by 4 cancel out. So we're left with y plus 2, and then over here we just have x plus 1 divided by 4. And then finally, to get rid of this plus 2, we can subtract 2 from both sides. So here the plus 2 and minus 2 leaves us with just y by itself, so y is isolated. And then on the other side we end up with x plus 1 divided by 4 minus 2. So this is just like the process for trying to solve for y, but in this case we can't get an answer of like a specific number of what y equals, because we still have the x variable over here. So this is the final answer for now, unless we know what x equals, in which case we could sub that in and then we would know what y equals as well. Okay, so let's talk about a math concept that I really only learned in grade 12, so I was very slow to learn this for some reason. But this is actually supposed to be taught in like grade 9 and 10, so I thought I would mention it in this video. So basically the concept is that you can add two different equations together. So like if your first equation is a plus b equals c, and your second equation is d plus e equals f, you can do like a really big addition together, and so we get a plus d plus b plus e equals c plus f. So you can add both left sides and make them equal to both of the right sides. And so the reason why I have all these variables over here is just to show that this is a general formula. But depending on the equations you're using, you would have different numbers and variables in here. So why does this work to add the two equations together like this? Well, first of all, we know it's okay to add the same thing to both sides of the equation. And so if we look at this, we're starting with a plus b equals c. So on the left side, we're adding d plus e, and on the right side, we're adding f. And since we know that d plus e equals f, we're adding the same thing to both sides. So that's why this all makes sense. And finally, I'm going to talk about cross-multiplying. So the concept of cross-multiplying is if you have an equation that looks like two fractions equal to each other, you can rewrite it in this form over here. And so I think I learned about this in elementary school, but I didn't understand the logic behind it, so I would always mix up which number multiplies. Does it end up being AD or is it A times C? And I would just get really confused because I was trying to memorize a rule and I didn't actually understand what I was doing. So hopefully now I can make it clear why this works so you won't have the same struggle that I did. So if we think about what are we actually doing here, we're going to start with A over B equals C over D. And we can multiply both sides by b. So over here on the left side, we have b times a divided by b. So the b's will cancel because you're multiplying by b and then dividing. So we're just left with a. And then over here, we have b times c over d, which is the same thing as saying b times c divided by d. And so next, what we can do is multiply both sides by d. So then on the left side, we have a times d. And on the right side, we have d times b times c divided by d. So again, the d's are going to cancel. And look, we're left with a times d equals b times c. So that's how we know that cross-multiplying makes sense. So that's all for this video, and I hope this has helped you to understand the main concepts of why algebra works and how you can apply it to these different situations. So there's really nothing that you have to memorize, there isn't any formula you have to memorize. You just need to understand it's always okay to do the same thing to both sides of the equation, and you can understand how you can use the inverse operation if you want to undo something. And so hopefully this will help you a lot in your math classes. And thank you very much for watching.